This story starts with an innovative car, one named after a star, and that star is Vega, the brightest star of the Lyra constellation. And this car would be the Chevrolet Vega, a vehicle destined to be Chevrolet's ambitious contender to combat the rising tide of foreign imports. Which brings us to the Cosworth Vega, a car with a compelling backstory, yet it fell short of living up to the expectations tied to its name. The so-called Cos Veg had a short-lived production run of just 2 years. It was a vehicle brimming with potential, but one that ultimately didn't reach the starry heights its name suggested. In 1966, GM built the Lordstown assembly plant in Ohio, costing $75 million, roughly $722 million in today's money. That's 2025. At its inception, it was hailed as the world's most advanced car manufacturing plant, with cutting-edge welding machines completing 90% of the 3,900 body welds. Also boasting computerized systems for sub-assemblies, conveyors and quality control, setting a new standard for automation in the industry. GM optimized Vega transportation by introducing the innovative Vertipack railcar system. These railcars, capable of carrying 30 vehicles mounted vertically, significantly enhanced efficiency, but this system would be discontinued following the 1977 Vega model year. On October 3rd, 1968, GM Chairman Jim Roach announced plans for an innovative small car to debut in 2 years. This lightweight vehicle would cost less than a VW Beetle, feature an advanced aluminium engine and utilise a cutting-edge automated assembly process. This announcement caught many by surprise, as GM had been seen lagging behind Ford in the market. This bold declaration suggested that the industry giant was stirring to life, with a car poised to outclass the wave of imported competitors and be known as Project XP887. GM Central Corporate Engineering Team led the project's design and development, refining the concept before transferring production and distribution responsibilities to Chevrolet. Chevrolet then managed manufacturing, marketing and logistics, playing a key role in bringing GM's vision to market efficiently. The initial designs for the Vega actually dated back to 1967 and included a rear engine configuration. However, this idea was abandoned due to concerns over potential comparisons with the problematic Corvair. The Vega would also utilise the all-new GM H platform, a compact rear-wheel drive design that would be produced from 1971 to 1980 and be shared with the Chevrolet Monza, Pontiac Astra, Buick Skyhawk and Oldsmobile Starfire, all designed as affordable alternatives to the influx of compact imports. The Vega's engine, however, was another story. This defining feature was the 2.3 litre or 140 cubic inches overhead cam 4-cylinder, commonly referred to as the Chevrolet 2300, Quad 4, and after 1976 as the Durabuilt 140. This innovative powertrain was a result of a collaboration between GM, Reynolds Metal Company and the Sealed Power Corporation. It would be Reynolds who developed the hyper-eutectic aluminium alloy called A390, made up of 77% aluminium, 17% silicon, 4% copper, 1% iron, with traces of elements like phosphorus and titanium. This alloy not only allowed for faster die casting, but also reduced production costs compared to traditional aluminium engines. The finished engine would weigh only 36 pounds or 16 kilos, its block weighing 51 pounds or 23 kilos less than a 153 cubic inch or 2.5 litre inline-four cast iron model used in the Chevy 2 Nova. This engine featured a cast iron cylinder head for strength, an overhead cam, a compression ratio of 8:1 and was adjusted for unleaded fuel. There were 2 carburetor options: the standard single barrel Rochester monojet engine code L13 pushing 90 horsepower and a double barrel Rochester 2GV engine code L11, which also featured a revised camshaft that increased its power to 110 horsepower. However, this tall long-stroke engine did have a tendency to vibrate, but this could be mitigated by the use of rubber engine mounts. Unfortunately, when an aluminium block iron head engine overheats, the differing expansion rates of these metals put significant stress on the head gasket, potentially causing it to fail. This failure allows coolant and oil to mix, leading to coolant loss and reduced oil lubrication. Consequently, severe overheating can warp the softer aluminium, leading to permanent engine damage. The Vega would also go on to include standard features not usually found on other small cars of the 70s, such as front disc brakes, steel guard door beams, double panelled roof and coil springs for all four wheels. John DeLorean, being John DeLorean, at the time Chevrolet general manager, immediately recognised the need for an image booster for this new Vega. In the meantime, the Chevrolet 2300 engine would also go on to better things, starting in 1969 with John DeLorean sending a memo to Jim Musa recommending they reach out to Keith Duckworth of Cosworth Engineering to explore their potential interest in this new high silicon content block for the possible use as a racing engine, aiming to position the Vega as a strong contender in SCCA production racing. John DeLorean sought the expertise of Cosworth to create a high performance variant of the Vega engine. Cosworth, famous as a Formula 1 engine builder and renowned for producing numerous race winning engines including the legendary Cosworth DFV engine, Keith Duckworth found the idea of collaborating with Chevrolet appealing and travelled to the US to examine the Chevrolet 2300. Impressed by its structural integrity, he decided Cosworth were interested and began discussions with Chevrolet's engineers in 1969. Known as Project EA at Cosworth, the engine underwent significant redesigns, including downsized internals and the creation of a bespoke dual overhead cam head inspired by the BD series. It featured dual Weber 48mm DCOE carburetors and incorporated a dry sump oil system for enhanced performance. The outcome was a lively and potent 260 horsepower 2 litre or 1995cc naturally aspirated racing engine, or EAA engine as named by Cosworth. The EA designation was used during the development phase at Cosworth, while EAA signified the completed engine from the project. Built on a Chevrolet block, it marked Cosworth's first stock block engine not to be based on a full design. The dry sump system used in high performance engines relies on an external oil reservoir and multiple pumps. Scavenging pumps transfer oil from the engine to a reservoir while a pressure pump returns it. This design improves performance by preventing oil starvation during fast manoeuvres and enhanced cooling and oil flow. However, it is more complex and costly than the wet sump systems used in domestic cars. DeLorean envisioned a transatlantic racing series focused on 2 litre championships, with the collaboration aimed at developing a competitive racing platform for the Chevrolet Vega. In March 1970, John DeLorean dispatched engineer Calvin Wade to England to explore advanced cylinder head technology and begin discussions towards developing a full-blown racing engine. It was during the summer of '70 that DeLorean gave Wade the green light to develop a prototype Cosworth Vega engine. Despite a limited budget and pushback from managers between Wade and DeLorean, the project, once approved by DeLorean, could not be stopped. By autumn of 1970, Cosworth had received the first fully machined pre-production blocks from Chevrolet. By March 1971, the first prototype engine was put through its paces on a dynamometer at Cosworth, showcasing an impressive 290 horsepower, delivering what was described as useful horsepower. Although production of the Vega began in June 1970, its September 10, 1970 launch was met with a lukewarm reception. Its underwhelming debut was attributed to primarily several challenges, with the most significant being the GM strike that occurred between September and November 1970, which essentially is how the Vega became a 1971 model. On release, it was offered as a 2-door hatchback, notchback, wagon and sedan delivery, with all models being equipped with the new Chevrolet 2300 engine. Despite this, the Vega quickly gained recognition, earning Motor Trend's 1971 Car of the Year award, which was announced in November 1970. This title demands the model to be a new model or significantly updated. The Vega's strength as a contender was evident given its competition in 1971, including the AMC Matador, Ford Pinto and Pontiac Grand Safari. In mid-1970, 1971, a GT package, RPO code Z29, was introduced for Vega coupes and wagons, using the L11 engine, which pushed 110 horsepower, with an upgraded suspension, which much improved handling, black rocker panels, chrome trim, sporty wheels, and unique GT emblems. Interior enhancements included a tachometer, adjustable seats, and a 4-spoke steering wheel. In June 1971, Wade's prototype pushed 170 horsepower, using dual double-barrel carburetors. The pressure on Cal Wade and Cosworth to deliver results mounted rapidly. Over the following year, Cosworth faced repeated catastrophic engine block failures, with a troubling tendency for the blocks to split horizontally below the cylinder bores. Meanwhile, Chevrolet took a different approach, focusing on developing a street-ready version of the twin-cam cylinder head design that prioritised both reliability and high performance. Lloyd Roos, then Assistant Chief Engineer at Chevrolet, saw this as an opportunity to enhance the Vega's reputation and bolster Chevrolet's sporty image. He envisioned creating a powerful engine, a true street fighter that could easily rival the BMWs of the era. Sales of the Vega struggled as the American public showed little enthusiasm for its revolutionary die-cast lightweight aluminium block, and its underwhelming 90 horsepower base engine left a lot to be desired. Additionally, the Vega GT failed to bring in the flair needed to elevate the standard Vega's lackluster performance. During Easter of 1972, GM President Edward Cole tested 3 Vegas, a base model, an all-aluminium V8 prototype, and a Cosworth in prototype form, which led him to secure Engineering Policy Group approval for DeLorean's production request for the Cosworth. The Environmental Protection Agency, or EPA, certification was soon gained. Wade then launched a 12-car development program to test the engine's performance across various conditions, with the car achieving 122 miles per hour at GM's Desert Proving Ground. The engine, in racing form, would go on to power the Chevron B23 and Lola T290 race cars to victories in the 2-litre class during their initial outings in the European 2-litre Sports Car Championship. However, the engine faced some reliability issues, which seriously hindered its potential to achieve the status required for Formula 2. As a side note, Hot Rod magazine conducted tests on a Vega prototype in July 1972. The car featured a modified 302 cubic inch or 4.9 litre all aluminium V8 engine, derived from the 283 cubic inch or 4.6 litre units used in the Serve 1 research vehicle, equipped with high compression pistons, a 097 Duntov camshaft, and a quadrajet carburetor. The engine was paired with a turbo hydromatic transmission and factory components. Impressively, it achieved a sub 14-second quarter mile. In 1973, having completed all the R&D and recognising the engine's impressive performance pedigree, DeLorean aimed to create a detuned version of the 2-litre engine for street use, marking a divergence between Chevrolet's racing and street engine designs. Cosworth proceeded with this plan, developing a new 2-litre Cosworth Vega street motor that featured robust internals similar to the racing engine, but having a lower compression ratio and different valve timing. It featured a new dual overhead cam and Bendix electronic fuel injection, replacing the Lucas mechanical injection to accommodate a broader range of operating conditions and comply with emissions standards. While the bore, stroke and valve sizes were unchanged, the engine omitted the EA dry sump lubrication system. The focus was on emission control without sacrificing power and ensuring compatibility with the existing block and Cosworth head. By April 1973, the Cosworth Vega's design was finalised and 2 prototypes were built for EPA emissions testing. The initial Cosworth pilot program took place at the Ste-Thérèse assembly plant in Quebec. This occurred while the Lordstown plant was shut down due to a strike at the neighbouring Fisher body stamping plant. 7 neutral silver Cosworths were produced during this program for engineering evaluation. Engine blocks were delivered to Cosworth, but many failed their pressure test, piling up while a solution was sought. Those that successfully passed testing were released, with the first version making a dramatic debut in Guidwood's Lola T292 at Imola on June 3rd, 1973. However, despite Duckworth's tireless efforts, they failed to achieve lasting success, and their persistent reliability issues ultimately led to the cancellation of the racing project. The Cosworth Vega program was then publicly announced in August 1973 with a Car and Driver article highlighting the upcoming 140 horsepower Cosworth Vega. Further engine development ensued, including dynamometer testing, new camshaft profiles for improved low-end torque, and a tubular header replacing the cast-iron exhaust manifold. Despite earlier delays, the project now gained momentum with increased priority, engineering resources and funding. Some say Jerry Palmer rethought the Cosworth Vega styling from its original silver and black stripes to black and gold stripes, and others say it may have been influenced by Bill Mitchell's liking for the original JPS or John Player Special black and gold livery. However, it would be Jerry who would go on to design the gold stripes and lettering for the Cosworth Vega. The Cosworth Vega option would be designated Regular Production Option or RPO code Z09. Chevrolet then took the decision to limit Cosworth production to just 5,000 units. Since the Cosworth Vega's release was planned for 1974, Chevrolet dealers started accepting significant deposits from customers to secure early deliveries. However, dealerships had to meet strict requirements, including investment in specialist tools, mechanic training and Cosworth specific parts. Only the highest performing dealers who fulfilled these obligations were admitted into the program and guaranteed a car. By the mid-1970s, the fuel crisis and EPA regulations had transformed American cars into large, low horsepower, semi-luxury vehicles. As a result, Japanese, British and European automakers were beginning to get a strong foothold in America, with cars like the Toyota Corolla, Triumph, TR7 and 8 and the BMW 2002i. The Cosworth engine, originally developed with a 12:1 compression ratio and requiring high-octane Sunoco 260 fuel, underwent a number of significant downgrades during these stricter emissions regulations and the ongoing fuel crisis. Gradually, the compression ratio dropped to 11.25:1, then 10.5:1, followed by 9.5:1, and eventually down to a very restrained 8.5:1. Meanwhile, Vega sales in the US struggled. The GT model, though visually appealing, lacked the performance and allure to significantly boost the car's popularity. In response, John DeLorean, alongside Assistant Chief Engineer Lloyd Roos, proposed a sportier Vega equipped with a dependable street-legal version of the Cosworth racing engine. Their vision was to arm the Vega with enough power to rival the era's revered European sports sedans, such as the BMW 2002i or Alfa Romeo GTV. In January 1974, the Cosworth Vega's engine design was finalised, now featuring a stainless steel header for increased power, and its camshaft timing was adjusted to optimise torque for street use. Durability testing then commenced, with 2 cars built by project coordinator William Large. For 1974, the Vega received a body style facelift to meet the new safety requirements, mainly with the bumpers. By April, the engines ran cleanly for 40,000 miles, but the first car then exceeded hydrocarbon emission limits due to burned out exhaust valves, necessitating a 5-month recertification process. Chevrolet mandated that all engines endure 200 hours at full load, but the Cosworth engine surpassed expectations by lasting over 500 hours. During a clutch burst test, Cal Wade pushed the engine to 9,400 RPM without causing any damage to the clutch or engine. In September 1974, 3 cars, each in a different configuration, resumed mileage testing. These engines had the capacity to produce significantly higher horsepower, but unfortunately, to meet the stringent 50 state emission standards, GM had to substantially lower the compression ratio and implement additional modifications to ensure compliance for road use. In 1975, development focused on meeting the stricter emission standards. Key improvements included a redesigned fuel injection system for enhanced air distribution, an high-energy electronic ignition and larger catalytic converter to minimise power loss. The addition of a pulse air system eliminated the 6 horsepower loss typically caused by conventional air pumps. January 1975, the mileage test was successfully completed without any failures, even with one configuration complying with California's 1975 standards, making the Cosworth Vega the sole GM vehicle certified for all 50 states, using a modified 3.16-inch or 80mm stroke. This was paired with a Bendix fuel injection, which incorporated 4 injectors, an ECU, 5 sensors and 2 fuel pumps to manage fuel delivery. On March 14, 1975, the EPA granted the emission certificate, allowing a sale of the 1975 models to proceed. Production quickly ramped up to tackle the order backlog, with teams of 2 or 3 workers hand assembling 30 engines daily in the clean room at the Tonawanda engine plant in New York. This facility was originally designed for the ZL1 all aluminium 427 cubic inch or 7 litre V8 racing engine. Blocks were transported from Messina, New York to Tonawanda for construction. production and then shipped to Chevrolet's Lordstown assembly plant in Ohio for final vehicle assembly. Although 5,000 engines were produced, not all would go on to be used. Significantly, this would be Chevrolet's first passenger car with an electric fuel injection engine. On April 17, 1975, there was a media launch event for the Cosworth Vega at the Lordstown assembly plant and marked a significant milestone in the car's journey to market. It was also around this time GM considered converting Southgate, California, Arlington, Texas and Lakewood, Georgia, also known as the Atlanta assembly plant, to Vega Monza production. With the street engine done, it was now time to put it into a road car to make GM some money. At the Lordstown assembly plant, Cosworth Vega production was achieving a rate of 1.6 cars per hour, but unfortunately by this time only 1 in 6 waitees had stuck it out for their car. GM hoped that by combining the storied name and racing pedigree of Cosworth with the Vega GT, they could create a car that customers would be more interested in than just a normal Vega GT. The 1975 Cosworth Vega sported a distinctive appearance featuring tuxedo black code 19 acrylic lacquer paint accented with gold pinstriping. Notably, tuxedo black was unavailable on any other Vega models until 1976. Distinctive styling elements included gold Cosworth identification decals on the front fenders and rear panel. Gold pinstriping ran the length of the body along the belt line with curved double stripes over the wheel arches. A curved V accented the hood bulge with rectangular stripes on the rear deck circling the rear lights. Plus it had black wiper arms. Interestingly, this colour combination seems to mirror the designs featured on the 1976 and later Pontiac Firebird Trans Ams limited and special editions. Moreover, a similar design can be traced even further back to earlier models like the Lotus Elan, Europa and eventually the Esprit. The interior featured the Vega GT package. Options included custom black interior with perforated vinyl seat trim. RPO code ZJ1 was standard. However, black cloth seat inserts were available at an extra cost of $50 and approximately 16% of cars were equipped with white vinyl interiors. Also included was a gold engine tuned dash bezel, an 8,000 RPM tachometer and a Cosworth steering wheel emblem. Each Vega had a dash plaque with a unique production number engraved on it, starting at 0001 and located on the dash under the convenience pocket and above the radio. The Saginaw 4-speed manual transmission featuring a revised first gear for improved acceleration was the only transmission available on the Cosworth during 1975. It also included uprated GT springs, shocks and stabiliser bars, with the rear bar being larger than the Vega GT's. Other enhancements included a heavy duty radiator and provisions for the fast steer option 16:1 steering box, with a rear suspension similar to the Monza 2+2 and featuring a torque arm and 373:1 rear axle using a 7.5 inch ring gear sourced from the Monza 2+2 and available with or without posi traction code G81, plus rear axle limiting cables to minimise wheel hop. The ring gear in a vehicle's differential works with the pinion gear to transfer motion from the drive shaft to the wheels. Its size and ratio influenced the final drive ratio, affecting both acceleration and fuel efficiency, featuring an improved weight distribution compared to the GT to deliver exceptional handling. The Cosworth's gold-painted aluminium wheels, often referred to as pseudo mini-light, were manufactured by GKN, Guest, Keen and Nettlefolds in England. These wheels were specifically designed for the Chevrolet Cosworth Vega, featuring a 13-inch diameter and 6-inch width and shod with BR70 13B steel belted radial ply black wall tyres. Although front disc and rear drum brakes were standard, but strangely enough, power brakes, power steering and air conditioning was not available. By 1975, the Vega's weight had risen by 300 pounds, while the Cosworth engine's horsepower had dropped from the prototype's 140 horsepower to 110 horsepower. Despite its impressive performance and handling, its high price, just $600 less than a Corvette, and its unfulfilled prototype promises negatively impacted sales, which many blamed on the stricter EPA regulations. In its new form, the Cosworth only produced 110 horsepower, reaching 60 miles per hour in 8.6 seconds, hitting a top speed of 110 miles per hour and covering a quarter mile in 18.5 seconds. A pilot run of 1976 models were built in September 1975, with regular production beginning beginning in December. By 1976, the Vega adopted the floor pan, rear suspension and brakes from the Monza. All Vega models now featured the torque arm rear suspension and larger rear drum brakes, upgrades that the Cosworth models had already received upon their mid-1975 debut. Echoing the Vega, the 1976 Cosworth Vega received a facelift with a wider grille and recessed parking lamps, redesigned headlamp bezels, tricolour and revised shaped tail lights with an updated Vega hood emblem. The hood bulge stripes on the 76 were wider than the 75 to accommodate the new hood bulge style, and the rear deck panel stripes on the 76 stopped at rear light where the 75s circled it. A sky roof and 8-track player were also introduced in January. In February 1976, Chevrolet expanded the colour options for the Cosworth Vega, essentially to address poor sales in the south and west where the lack of air conditioning deterred buyers. The Cosworth Vega was now offered in 8 additional colours, while standard Vega models were available in just 14 colours, but would now have tuxedo black as an option. The 8 colours for the Cosworth Vega were antique white, code 11, dark blue metallic, code 35, firethorn metallic, code 36, mahogany metallic, code 37, dark green metallic, code 49, buckskin, code 65, medium saddle metallic, code 67, and medium orange, code 78, as well as the original tuxedo black, code 19. To reduce costs, Chevrolet initially repurposed the decals originally designed exclusively for the black Cosworths with the new colour options, as can be seen by the black within the logo lettering. However, with these new colour options, the stripes often did not show up as well on certain coloured models. To alleviate this, later production logos with clear backgrounds were introduced and appeared on a few very rare models. In 1976, the seat material changed to a grained vinyl. The optional cloth seat was made from houndstooth type material. Also, 2 new interior colour options, firethorn and buckskin, could be selected in either grained vinyl or sport cloth for an extra $18. The seat fabric also changed from the perforated vinyl in 75 to a solid vinyl in 76. The lower rear seat now being 2-piece as opposed to 1-piece in 75. A Borg Warner T50 5-speed manual overdrive transmission, RPO code M75, with a Ford 10:1 rear axle ratio became optional, again with or without posi traction, whereas the 1975 offered only a 373:1. The wheels remained mostly the same, except that the lug nut centre on 75 wheels had black inserts, where the 76 did not. The tailpipe on the 75 was a 2-piece design, but for 76 this was changed to a single piece. Finally, and after much criticism around the fenders, enhanced rust proofing was put in place. In fact, in a comparison track test against competitors like Alfa Romeo, Saab, the Mazda Cosmo Rotary and Lancia, Road Test magazine of July 1976 praised its world-class handling. Thanks to a few modifications, the Cosworth Vega had slightly better performance, accelerating from 0 to 60 in 7.7 seconds with a top speed of 114 miles per hour and completing the quarter mile in 16.2 seconds. Production of the Cosworth Vega ceased on the 23rd of July 1976 with a medium saddle metallic model. After a production run of 7 years and 1.9 million units built, the Vega and its aluminium block engine was discontinued at the conclusion of the 1977 model year, 3 years ahead of schedule, but its siblings, the Monza, Skyhawk, Starfire and Astra, continued in production in one form or another until 1980. Out of the 5,000 engines produced, 3,508 were installed in Cosworth Vegas. Some of the surplus engines were scrapped, while some found their way back into racing. The Cosworth's slow sales were likely due to its steep price tag of $5,916, approximately $32,600 a day, a significant premium compared to the base Vega hatchback, which started at $2,478 or around $13,650 today, making a Cosworth nearly double the price of the base model. Also, at this this time $6,000 could buy an Oldsmobile 98, with the Cosworth Vega being only $900 less than the 1975 Chevrolet Corvette. The Cosworth Vega's reputation suffered due to early rust problems around the fenders and numerous recalls, so resulting in its limited production run. During the Vega's 7-year run, a total of 2,006,661 were produced, including 3,508 Cosworth models. Of these, 2,061 were manufactured in 1975, 1,447 were produced in 1976. The highest known factory installed dash plaque is 3525 and was likely on the third to last Cosworth Vega produced on July 23, 1976. The final car that day, a medium saddle metallic, had the dash plaque 3522. The discrepancy in plaque numbers was probably due in part to how the plaques were issued to the production workers. As a side note, Cosworth Vega 0001, the original Chicago Auto Show vehicle with a clear plexiglass hood, is in the GM Heritage Collection. The Chevrolet Cosworth Vega, launched in 1975, sought to merge performance and innovation in a compact package, powered by its innovative 2-litre 16-valve twin cam, developed in conjunction with Cosworth engineering, but it would be emissions restrictions that would ultimately reduce its power to 110 horsepower. Despite its many enhancements over the base model, its steep price and modest performance led to a total of 3,508 units being sold during its 2-year production run. This makes the Cosworth Vega one of Chevrolet's rarest vehicles, significantly rarer than the iconic '63 Corvette split window coupe with around 13,000 produced.